With the help of a balanced chemical equation, we can calculate how many grams of a particular compound takes part in the chemical reaction and how many grams of the product may be compound or element forms. One of the numerical related with this I am going to present here. Look at this. How many grams of potassium sulfate are obtained by reacting 20 gram of potassium hydroxide with sulfuric acid? Now here we have reaction of potassium hydroxide and sulfuric acid. That's why I have written here potassium hydroxide and sulfuric acid, and its product is potassium sulfate and water. And I balance the equation. You know how to balance the equation. And after this, the question is related with what? 20 gram of potassium hydroxide when takes part in the chemical reaction. Then how many grams of potassium sulfate forms? It means we are related with potassium hydroxide and potassium sulfate. That's why I am going to write the molecular weight of potassium hydroxide. And there are two molecules, that's why 2 is written. And atomic weight of potassium is 39. Oxygen is atomic weight is 16. Atomic weight of hydrogen is 1. With the help of atomic weight contained in this molecule, we can find out the molecular weight. And in the same way, we are related with this also. 2 multiplied by 39 plus sulfur. Sulfur is atomic weight is 32 or atomic mass is 32 plus 4 atoms of oxygen each having atomic mass 16. And if we multiply all these, just for example, if we multiply these two, we'll get 78 plus 32 plus 64. This way, if we get the result, 2 into 56, this is equal to 112, and here it is equal to 174. Now, conclusion of this addition and multiplication is when 112 gram of potassium hydroxide reacts with certain amount of sulfuric acid, then 174 grams of potassium sulfate forms. That's why we can write 112 gram of KOH forms 174 gram of K2SO4. Then 1 gram of KOH forms 174 divided by 112 gram of K2SO4. Now our question is, how many grams of potassium sulfate forms when 20 gram of potassium hydroxide reacts with sulfuric acid? That's why let's take 20. Therefore 20 gram of potassium hydroxide forms how many grams of potassium sulfate? 174 divided by 112 into 20. This much gram, and if we multiply 174 with 20 and if it is divided by 112, then we'll get 31.07 gram of potassium sulfate. This way we can solve this numerical problem. Now I told you how to solve the numerical problem related with balanced chemical equation. Now I want to present limitations of chemical equation. Now look at this. Some of the points or some of the matters cannot be represented by a chemical equation. What are those matters which cannot be represented by a chemical equation? Physical state of reactant and products cannot be represented in a chemical equation. Look at this chemical equation. Here it is written in the form of formula. If we are writing in words also, but even after writing with the word, the physical state, whether this potassium hydroxide is in the form of solution or solid, and sulfuric acid in the form of solid or liquid, it's not clear. That's why physical state of reactant and product cannot be represented by chemical equation. Another, condition required for the chemical reaction to occur. I mean to say, two compounds or one element or another compound when reacts with each other, whether the heat is needed or not, whether the pressure is applied or not, and what kind of catalyst is used or not, these conditions cannot be obtained or cannot be understood by looking at the equation. Here it is not given in which condition this reaction is occurred. Now, third, time of completion of reaction cannot be understood by looking at a chemical equation. This equation doesn't say that how long it takes to complete the chemical reaction. Time taken by this chemical reaction for its completion is not represented in this equation. That's why a chemical equation cannot represent it. In the same way, concentration of reactants and products cannot be represented by chemical equation. Here, potassium hydroxide, let's say it is in the form of solution. If it is solution, then what percentage of solution is used? Concentration is 20%, 30%, or sulfuric acid, which concentration is used? It's not represented. A chemical equation cannot represent the concentration of the reactant and product. This is another limitation of chemical equation. Rate of chemical reaction. How fast this reaction occurred? It takes 10 minutes, 15 minutes or 20 minutes or just 1 minute cannot be represented by a chemical equation. This way, I told you two matters. One, a chemical equation gives us lot of information about its weight, how many grams takes part in the chemical reaction and how many grams of the product produces. In one side it gives lot of information, but there are some limitations. It cannot represent the physical state, it cannot represent the time of completion of reaction, concentration of reactant cannot be understood and product cannot be understood, what concentration it has, and rate of chemical reaction cannot be understood. There are so many matters which cannot be understood by looking at a chemical equation. That's why these are basic limitations or chemical equation.